Alright, part 2 of the everything reviewing AB calculus. We're going to start with, if you integrate acceleration, you will get the velocity, and it's going to be plus c always if they give you a point, such as if the velocity at time equals 2 is 5, then plug that in to find the value c. If you have velocity, you can integrate that to find the position. Also, same thing, you can find the c, and it'll tell you at a certain point. That's why they give you the point. And it analyzes the motion of objects. Now we move on to the fundamental theorem of calculus part 1. And if we do that, it just tells us that if you have a graph and the intervals from A to B, if you want to find the area of that graph, all you have to do is integrate from A to B, and you would have to do f of x, if you call this whole thing f of x with respect to x, and this would just be f of b minus f of a, where the capital F, if you take the derivative, will give you the original function. And that's it. You find that part and you just integrate. Also, we're using rectangles like this, and if rectangles were I'll show you an example right now. If the rectangles were like this, and you would have C here and D here instead of A and B, you would have to integrate. If you have a graph here, if you have to integrate that, you would just do f of y dy with respect to y, and go from C to D, up from down to up, and you would use horizontal rectangles instead of up and down with respect to x. And we keep on going. Fundamental theorem calculus part 2, where it says if you have f of x, then you have from a to x the interval of f of t dt. If f is continuous, and then f prime of x is equal to f of x. It just tells you that if you integrate, you can differentiate to get the same thing back, or differentiate and integrate to get the same thing. And now we go on to the mean value theorem. And the mean value theorem, it just says that f prime of c, so the slope at a tangent c, is equal to just the secant line, which I'll just sketch for you real quick. I just bust my orange marker right now. If you have a curve, if you have C here, which is going to be parallel to the secant line right there, we'll call that A, we'll call that B, we'll call that C. That line is going to be parallel to that. That's why this is a secant line. The slope of a secant line right there crosses the curve twice. The slope of this line is the tangent line. That's why it only hits the curve once, and we're finding value C. You usually have to do this for free response questions. That's called the mean value theorem. Rolle's theorem also states Rolle's theorem. It just tells you that in between interval from A to B, if it's closed, if it's continuous, and open when it's differentiable, if you have the curve with A to B, there's always going to be a point C where the slope of that at point C is going to be 0. Because if you have a root, if they have the same value, they'll often converge and change slopes. Here it's going positive, negative slope, positive, 0, negative. You always have to change signs. Keep on going. We have L'Hopital's rule. L'Hopital's rules work with limits. Limits, if we do limits really quickly, I'll just show you a quick limit right here. If you have, instead of L'Hopital, we'll do, if it has the same power, we'll do 2x over x squared is going to be just 2. It makes pretty sense because you could just cancel them out. But what if it was plus 3? You just use the coefficients of the same power if they are the same power, the highest power, and if they are different powers. So if the top has a greater power, then if it's x to the cube plus 3 over 5x squared, it's just going to be infinity. And if the bottom is greater, then it's just 0. And L'Hopital's rule says if your limit that you're evaluating, if you're going to the limit equals 0 of sine x, whatever you want, it can be any function. I'm just using sine x over x. if you plug in 0, because you usually just plug in 0 for limits, you're going to get sine of 0, which is 0 over 0, which is 0 over 0. If you have 0 over 0 over infinity, that's indeterminate form. You need to use L'Hopital's rule, which just states find the derivative independently of the top and the bottom. So the top would just be the limit as x approaches 0 of cosine x over x, the derivative of x, which is just 1, and plug in 0, you're going to get 1. That's just L'Hopital's rule, just applying derivatives. Do not use quotient rule, please. And you have to know that it's 0 over 0 or infinity over infinity. Let's keep on going. Trig derivatives. If you have, we'll call this y, and we'll call this the derivative side y prime. If you have sine x, you're going to have cosine x, the derivative. If you have cosine x, you have negative sine x. If you have tangent x, you're going to have secant squared x. These are just to memorize. If you have cotangent x, you have cosecant squared x. If you have secant x, you're going to have secant x tan x. And if you have cosecant x, you're going to have cosecant x cotangent x. Alright, and that's just derivatives. And if you want to integrate it, just integrate backwards. So if you integrate cosine x, you're going to get sine x. If you integrate sine x, you're going to get negative cosine x. If you integrate secant x, so if we do this and we call this f and we call that capital F, if we integrate it, we are going to get secant squared x is just tangent x. This integrates cosecant squared x, you get cotangent x. And of course plus c for all of them since they're indefinite integrals. Alright? That's how you integrate and differentiate trig functions. And if we keep on going, we're almost there. Average value of a function, might need to use a third part for this. B minus a, if you have interval 1 over b minus a from a to b of f of x dx. That's going to be your average value, y average, often called that. That's that right there. If you have Riemann sums to approximate the area under a curve, you can use MRAM, LRAM, or RRAM. LRAM just states that if you have interval, we'll say we had 3 intervals. For every interval, so if you have 1 interval here, 2, 3, we'll call that 1, 2, 3. We'll call RRAM and MRAM. MRAM is just the midpoint. RRAM is the right hand approximation. LRAM, you just use the left-hand most point of each interval. RRAM, use the right-hand most point of each interval. MRAM, use each interval, use the midpoint of each one. That's it for Riemann sums. And let's keep on going. Volumes using cross sections. As we see, alright, we got 2 minutes right here. We'll go pretty quick. Cross sections using volume to determine volume. For squares, it's just a to b area squared. I'll just denote you calculate the area by using definite integrals or indefinite integrals if you want, and the area squared with respect to x. That's for squares. We'll put a square. If you have semicircles, you're going to have pi over 8 a to b area squared dx. And if you have equilateral triangles, you're going to have square root 3 over 4 a to b area squared dx. If you notice, pi is only in the semicircles. They also ask for isosceles triangles, which often are not tested, but just keep an eye out for that. If you have washers, you can do volume by washers, which is just the bigger radius squared minus the smaller radius squared dx, and you multiply by a pi to find the volume, which if we just do a really quick example, if we have an area that intersect right here and we're rotating around the x-axis, we go straight up wherever we hit the axis first, that's our small r. Wherever we hit the area, if we pass the area and then at the end of the area, that's our big R, big radius squared minus the small radius squared. And I'm going to end off the second part of this review for AB calculus, and I have differentials, derivatives, exponentials, inverse trig, and that's pretty much it. If you have any difficulties with a certain subject, just check out my individual videos. But that's the end of video number 2, and see you in the next one.